let's talk in a little bit more detail about what happens when a solute dissolves. If you think on a molecular level, there are two forces that you need to think about. The first is the forces between the solute molecules that are holding it into its solid form. And the second is the interactions between the solute and the solvent. So if the attractions between the solute and the solvent are stronger than the ones in between the solute molecules, the solute will dissolve. And those interactions tend to be things like water is what we call a polar molecule, so it has a negative side and a positive side, and it can overcome the interaction between sodium and chloride because it has strong interactions with both the sodium and the chloride molecules. We break things that dissolve up into electrolytes and non-electrolytes. So materials that dissolve to form something that can conduct electricity is called an electrolyte, electrolyte, and that's going to consist of some sort of ions in the solution that are transferring the electric current. Materials that dissolve and do not conduct electricity are non-electrolytes. And those are typically molecular compounds like sugar that can't break up into anions and cations. So if we look salt versus sugar dissolved in water, ionic compounds dissociate into the positive cations and negative anions. Molecular compounds don't break up into some sort of carbon plus hydrogen things. They don't dissociate at all. They dissolve as full molecules. Acids are molecular compounds that do ionize when they dissolve in water. The molecules are pulled apart because they have a strong attraction for the water, and they're going to form H plus cations along with anions. Now, we break acids up into two categories based on how much they ionize in water. Ones that ionize virtually 100% are called strong acids. So hydrochloric acid is a strong acid. When it's dissolved in water, it's essentially broken up into H plus Cl minus. Acids that only ionize a small percentage of the way are called weak acids. So hydrofluoric acid, notice we use this two-way arrow. That indicates that there's significant amounts of both the reactant and the product present. It's called equilibrium. And only 1 to 5% of the total is broken up into the ions. The rest of it is still as molecular HF entities. So strong electrolytes are materials that dissolve completely as ions. Those include ionic compounds and strong acids, and they're going to conduct electricity very well. Weak electrolytes are mostly as molecules, but there's a little bit of ion present, so they're weak acids are weak electrolytes. They can conduct electricity, but not nearly as well as strong electrolytes. And this last point is important. When compounds containing a polyatomic ion dissolve, the polyatomic ion stays together. So you don't get OH minus hydroxide stays together as OH minus. It doesn't break up further into a O and an H. So here's a question that the answer is already on there. Aqueous solutions of which would conduct electricity? Well, the answer is A, silver nitrate. Sucrose is a molecule, so it's a non-electrolyte. And ethanol is a molecule, so it is a non-electrolyte. Neither of those are acids. So the answer is A. Okay, a little bit about the difference between dissociation and ionization. When an ionic compound dissolves, you get anions and cations. That's called dissociation. Polyatomics stay together. Strong acids ionize into H plus and the anions. They don't dissociate. It's, just a different term for that. So some practice. Write the equation for the process that occurs when the following strong electrolytes dissolve in water. So take a minute, think about what it's going to break up into, and then we can work at it. CaCl2 is going to break up into calcium ions and then 2 chloride ions. HNO3 is a strong acid. It's going to be H plus NO3 minus, that's nitric acid. And ammonium carbonate, you're going to have 2 NH4 and a CO3 2 minus. And again, polyatomics don't break up any farther, so you just get these polyatomic ions, not some sort of N plus 4 H's or anything like that.